Hello Stings. In this video we will be looking at 3 examples of solving equations using our new technique with the 7 questions. Our first example is 5 over 6k plus 2/3 equals 4/3. So we will start out with our first question. Do I need to clear fractions? And the answer to that is yes. So what we do is multiply through by the common denominator. In this case, that common denominator is 6. When we multiply through, we are left with 5k plus 4 equals 8. So now we see if we need to simplify. We do not need to simplify either side. The variable is only on one side. So is there anything next to the variable? There is. There's a 5 being multiplied by the k and a 4 being added. So we go to the next question, which is, do I need to add or subtract? I can subtract 4 from both sides. On the left-hand side, that zeroes out the 4's, leaving 5k, and then 8 minus 4 is 4. Our next step is to multiply or divide to get the k by itself. So I can divide by 5 to get that k all by itself, and we end up with a fraction answer of k equals 4 over 5. Our next example is 5 times g plus 8 minus 2g equals minus 1. So, do I need to clear fractions? No. Do I need to simplify one or both sides? Yes, I need to simplify the left-hand side. So I will apply the distributive property, and that will give me 5g plus 40. Then we bring down the subtract 2g, and that all equals negative 1. We still need to simplify the left-hand side because we have like terms of 5g and minus 2g. That will give us 3g plus 40. All that equals negative 1. So now that both sides are simplified, we can move on. Is there anything next to the variable? Yes, so we're going to proceed to the next step, which is, do I need to add or subtract? And I do need to subtract 40 from both sides. On the left-hand side, the 40s will zero out. So that means 3g equals negative 41. So I move on to, do I need to multiply or divide? I do. I need to get rid of this 3, so in order to do that, since they're multiplying, I'll do the inverse operation of division, and what you do to one side, you do to the other. The 3 divided by 3 makes 1, so 1g is equal to negative 41 over 3. In algebra, we leave the fractions as improper fractions the majority of the time. In context, in an application problem, you might need to turn it into a mixed number. So our last example, and we will be using our questions again, we have 7c plus 12 equals negative 4c plus 78. So do we need to clear fractions? We do not. Do we need to simplify one or both sides? We do not. So is the variable on both sides? Yes, it is. So what we need to do is look at the smaller of the two, and that is the negative 4c. So we will add 4c to both sides so that we can get rid of the c on this side. Those zero out on the right-hand side. On the left-hand side, we have 11c plus 12, and what was left on the right-hand side was 78. Now we look on the side with the variable, and we see that c definitely has some things near it. So we move on to the next step, which is adding or subtracting. Since they're adding, we do the inverse operation of subtraction. These zero out. We're left with 11c equals 66. We move then to the next question. Do I need to multiply or divide? Since they are multiplying, we will be dividing. So we're going to divide both sides by the coefficient of the variable. In this case, that is 11. The 11s will cancel out, leaving c equals 6. So here we have 3 examples in which we don't have to use every single process that we have, but we do need to look at all of them to make sure that we end up with the variable alone on one side and all the numbers on the other side. So this has been 3 more examples of solving equations.